Hi, today we are doing our lesson on polar coordinates and polar equations, which is in section 9.5 in your book if you need to use that as a reference. If you watched the introduction PowerPoint from last time, then you have already become familiar with this diagram. When we talk about polar coordinates, we talk about the polar axis, which is on the positive x-axis. We talk about that coming out of a point called O, or the pole, which would be like the origin on the Cartesian coordinate system. And then we would talk about graphing a point down this ray, which is called the directed distance. And that point then is the result of angle theta, which runs between the polar axis and the directed angle, and the distance down there. So when we talk about these coordinate points, we're actually using that distance and direction that we talked about in the introductory PowerPoint to graph the point r theta. Now the thing that's interesting about these graphs, unlike Cartesian coordinates, is they can be named in multiple ways. So I showed you an example of an angle that was named in several different ways in that. Now you can use these coordinate expressions and memorize them if you would rather. This is what it would look like if it's going a positive distance. Then you would take theta plus or minus 2n pi depending on where your angle is. And then if it's a reversing the direction point, then you would have a negative distance and then 2n plus 1 theta. Well, these are just two more things that you have to memorize, and you can do that, that's fine. But I think it's much easier to just understand what's going on, and then you don't really have to memorize anything new. So what I mean by know what's going on is we're going to look back and use a couple of different things that we've learned so far in trig. The first thing we're going to use is the fact that we know if we start at the positive x-axis and we travel in counterclockwise direction around the circle, that all of those angles are going to be a positive angle, whether it's in degrees or whether it's in radian measurements. And if we start at the positive x-axis and go clockwise around the circle, all of those angles are going to be negative, whether they're degrees or radians. So we're going to use those facts as we work through today's lesson, and that way we can kind of avoid some memorization. The other thing we're going to use is something we learned in vectors. And remember, if we had a vector, which is what this is, it's a directed distance, and we have this point here, so that's a positive direction. So for instance, think about that maybe in terms of just vector v. But what if I ask you about vector negative v? Remember, the negative in front of the vector changed the direction, so instead of graphing up to this point, now we would go in the opposite direction and graph down to that point this way. So this distance down here is our negative r's, and this distance up here would be our positive r's. And remember, the negative r doesn't mean you're going in the negative direction technically, it just means that you change direction, so you're still going that same positive distance but in the opposite direction. So we're going to use those two facts to help us come up with these angles, and it makes it a whole lot easier. So this is just an example. It's not on your note page. I just thought we would talk through one before we started, and it might make it a little easier as we're working through the problems. So the angle is r theta, and this example is 2 pi over 3. So the first thing you're going to do is actually graph 2 pi over 3. When you graph a polar coordinate, you always graph the angle first, so pi over 3 would be roughly in that direction. And then down that directed line, we do our distance. Our distance is positive 2, so that means from the pole, which is right here, we're going to graph out 2 runs, or 2 rings, and that's going to put that point right there, and that is my point 2 pi over 3. Okay, so remember that we started here and we graphed up to positive pi over 3. We could also be looking at this same angle 2 runs out, but we know now we can travel in the negative direction around the circle. So that means that I can go from here, but this time I'm traveling around this way and I'm stopping at that point. So if I'm traveling this way, I'm going in the negative direction, so I'm still plotting 2 rings out, so that's going to be 2, but then it's not just to here, which is positive 3 now, it's all the way around here, which would be negative 5 pi over 3. So that's a second way that you could name that exact same point. So we've went from the polar axis in the positive direction to the point, from the polar axis around into the negative direction. Okay, so that gives us a few representations, but there's still another way that we can do that. Remember, in this point, these 2 points, we had one point that represented positive distances of r and one that represented negative distances of r. So in order to represent the negative distance of r, we still think about the same pi over 3, and it would have been right here on this rung, except the negative r means it would change direction. So instead of graphing in this direction, we're going to graph at the same angle but the other side of it in that direction. And then I would graph 2 rings out, so that puts me right there. Okay, so then we'll use that same idea of positive and negative angles to do that. So first off, remember we went in the negative direction, so I do have to make sure that I represent that direction as a -2 because it is in the negative direction. And then the next thing I'm going to do is get my angles. So I'm going to start here, and I'm going to go all the way around in the positive direction to that point. So in other words, what is the pi over 3 angle that I'm going to find in the third quadrant? Well, the positive is going to be 4 pi over 3. But there's still one more representation I can get from my negative direction, and that's if I start here and I go this way to that point in the negative direction. So if I go that way to the point in the negative direction, that's at the angle -2 pi over 3. So I have 4 points all representing the same polar coordinate. I have 2 pi over 3, positive 2 pi with a negative angle, which is -5 pi over 3, and then I have a negative directed distance with 4 pi over 3 and a negative directed distance with -2 pi over 3. So it's not a hard concept if you just apply what you've learned, and you don't have to memorize those expressions. The thing you do need to be very careful of is when you're doing this, make sure you get the -2 with the right angle. Okay, so you really have to be careful and make sure your directed distance lines up, because if I say 2, then I can't say the negative angle of or the positive angle of 4 pi over 3 because my point would be up here and I'm talking about an angle down here. So you just have to be very careful. Okay, so let's work through some problems. So in this first set, we're going to, 1, plot the point and find 3 additional polar points, and we're going to be representing those polar points between -2 pi and +2 pi. Technically, there's an infinite number of points that could be represented here because you could keep going around your circle multiple times and it wouldn't be a big deal at all. However, since we are giving you this restriction, and I speak for all the teachers on the Pre-AP Pre-Cal team, I expect my answers given in this restriction. If you give me a point that's outside this restriction, please don't expect to get credit. So I need you to pay close attention. All right, so the first thing you want to do is plot the point. Now, you don't have to draw those circles every time like I did on the example. We're actually just going to mark those distances down the line. Okay, so the first thing I need to do is figure out where -3 pi over 4 is going to be. So -3 pi over 4 is going to be this angle right around to here. And so So I'm going to backtrack here just a minute. I realized the minute I said that, that I did not graph -3 pi over 4. So let's try that again. Let's actually get the right angle that we need down here, which is going to be -3 pi over 4. So the first thing you do is graph that angle. Once you graph the angle, then you're going to graph the distance down this angle. So we're going to put 1, 2, 3 marks down the ray, and that's where I'm going to put that dot. Okay, so you don't have to draw the circles, you're just going to mark them off on the directed ray. So once you plot the point, then to give 3 additional points, you have to figure out what you've already used up. For instance, I went to -3 pi over 4, so negative here. So if I'm doing that, that's the angle that's going from here to here. And so that's what I graphed to begin with. So if I went in the negative direction, then the first additional point that I'm going to give would be that same +3, but now I'm going to rotate in the positive direction. So I'm going to start here and I'm going to go all the way around to here. Okay, so that's my second one. So what would that angle be if I go all the way around my circle down there? That would be 5 pi over 4. So that gives me 1 additional point. All right, so I need 3. So now I'm going to take this particular point and I'm going to reverse the direction. So instead of going 3 down my angle this way, I'm going to extend that line all the way back this way, and I'm going to go 1, 2, 3 this way, and I'm going to put that point down. Well, my next 2 points are going to be the negative distances. So since this was positive 3 this way, I'm going to go negative 3 for one of them and negative 3 for the other. Not every time will you have to give me 3 points. It might just say give me 2 more points, or give me 1 positive and 1 negative direction point. So pay attention to the directions so you know exactly which way you need to go. So the first one we would get by starting at the positive x-axis and going up to that point. And if I do that, what angle would that be? If these are pi over 4s and I'm in the first quadrant, well, that has to be positive pi over 4. Now, what is it going to be if I start in the positive x-axis, but this time I'm going all the way around to that point right there. And so I'm going in the negative direction. So when I go in the negative direction, that would be negative 7 pi over 4. And so that would give me 3 additional points. The original graph with the positive angle, reverse the direction, reverse the direction. All right, moving on to the next one. So these would be all the points that go along with that. Okay, so let's move on to the next one. So the first thing we're going to do is graph it. So we graph negative 7 pi over 6. So I'd start here and then going in the negative direction, I'm graphing around to here. So negative 7 pi over 6 would be in this quadrant. And if I'm going 0 distance down that pole, then I'm actually just staying put right there. So this one is at the pole, which makes it super easy to find the directed distance because it's going to be 0 all the way through. So I'm going to have 0, 0, and 0. So all I have to do now is figure out what my angles are going to be. And so you have to still think direction even though you're not moving off of the pole. So remember, this one went in the negative direction. So now we need to go in the positive direction. So what would the positive angle be if I go positive to there? That would be 5 pi over 6. All right, and then in theory we would change directions, so you can kind of think about, we would be down here is where we would be finding our angles. So if I go from here to here in the negative direction, that would be the pi over 6 angle in the negative direction, so that would be negative pi over 6. And then if I start here and go all the way around to where this line would be, I'm going to get negative 3 pi over 2. So that one, the directed distance, was super easy to find, but you can see how I still drew out the pictures here to help me reason through my positive and my negative direction angles. Just makes it easier that way. All right, so moving on to this last one, we'll graph it. And so when we graph this one, we graph to negative pi over 2, which should be right here, and then we have to reverse the point. So, well, to get at, I guess I should go ahead and graph the first one there, huh? So then I would go 1, 2, and that would be my 3 marks down the line to represent this point, and that would be the point negative 3, negative pi over 2. All right, so if we went from here to negative pi over 2, then we're going to have what? How would we do that? So we're negative 3 pi over 2. Think about that for just a minute. Okay, so if this is negative 3 negative pi over 2, then I'm going to have the same point, negative 3, but going in the positive direction around to here would be 3 pi over 2. All right, so then if we want the other points, we're going to reverse the direction. So now we're going to go 1, 2, 3, and I'm going to be talking about this point right there. So when I do that point, I'm up here at the pi over 2 axis. So I reverse my direction, which now makes it 3. And then I would go from here to here, which is pi over 2. and then I would go from here all the way around to here, which would be 3, negative 3 pi over 2. So I really encourage you to make sure you draw those pictures so you don't accidentally say, oh, it's negative 3 positive pi over 2, or it's positive 3 pi over 2. When you have a visual there, it's much easier to not make that mistake. So that would be coordinates. So it gives you an idea of how to plot coordinates. All right, so the next thing we're going to talk about is a coordinate conversion. So I'm going different kinds of conversions through this lesson, but right now we're talking about points. So I have a polar point and I want to make it look like a rectangular point, where I have a rectangular point and I want to make it look like a polar point. So these are all in problem 2, are all polar going to rectangle as we work through the problems. Okay, so the first thing that we want to make sure we do is draw a picture. I will expect to see that in all the problems that you do, no matter how difficult or how easy they are, a quick sketch of where that point is. It's real important to get in the habit of doing that, and then sometimes by doing that you can answer the questions without having to do any of the conversions at all, because you're just going to know how that point would lay on the rectangular system. So especially if it's like a quadrantal angle or something like that. And then we're going to use conversion facts. And the facts that we're using are x equals r cosine theta and y equals r sine theta. So we've used those both before, that's nothing new. And that's how we're going to work through these problems. Okay, so we have the first one at 2 pi. So when I graph it, then how am I going to do that? Well, I go from the positive x-axis around here, and that's going to be my pi, that's my angle. And then how many spaces down that ray? 2, 1, 2, so that's going to put that point right there. Hopefully that looks familiar. That's just a quadrantal angle in polar form. So if I were going to give the rectangular point for that, how would I graph that point on a normal Cartesian graph? I would say that is the point negative 2, 0. And so I could be done if I have my picture. If I don't have my picture, or it's not something quite that simple, then I use my conversion facts. So I would do x equals r cosine theta. And so I would say, okay, to get my x coordinate, I'm going to use r, which is 2, and then I'm going to do the cosine of pi. So what is the cosine of pi? Well, that's negative 1. And then when I multiply it by 2, look at that. I get negative 2, and that's what my x coordinate was. Okay, so to get my y coordinate, I would do y equals r sine theta. So that means I'm going to take r, which is 2, and then I'm going to do sine of pi. And so what is sine of pi? Sine of pi is 0 times 2, which gives me a y value of 0. And there you go. There's my graph. However, if I graph this from the beginning, I didn't actually need to do all of that to be able to get that answer. And so I would be perfectly happy with this being my answer. And if you had the picture to support your answer, then that would be all that you would need as supporting work. If you didn't have a picture, then 1, I'm asking you to be sure you draw your picture, but 2, that's where these conversions come from. All right, moving on to B. So the first thing again, we said we were going to draw it. So 5 root 3 pi over 6. So pi over 6 is going to go this way. That's where my pi over 6 is. And then I'm going to go down to root 3. So that's where my point is. Okay? So remember, we're talking, this is your theta that we were talking about, your directed angle. Well, this one isn't quite as easy as a quadrantal angle, so I am, in fact, going to use my conversion facts here. So I'm going to say x equals r cosine theta. And I know that x equals my r is root 3, and then I'm going to multiply that by the cosine of pi over 6. Alright, so what is the cosine of pi over 6? That's root 3 over 2 times root 3. And I know that root 3 times root 3 is root 9, which is 3 over 2, so that's going to make my x coordinate 3/2. To get my y, I'm going to have y equals r sine theta. And so that means I'm going to have y equals r, which is root 3, sine of pi over 6. And what is pi over 6? Well, that's just 1/2. So when I take 1/2 times root 3, then I get root 3 over 2. So now I know my coordinate point in rectangular form would be 3/2 and root 3 over 2. So that's what I would be having as my final answer. All right, so pretty basic, pretty straightforward. So this last one, 5 45 degrees. Well, I know my 45-degree angle is right here, and that's 1, 2, 3, 4, 5. So that's where my point would be. So just put your marks down the line as you go. Remember, this is your theta that we're talking about right here. So I'm going to say x equals r cosine theta, and so x is going to equal the r, which was 5, and I'm going to say cosine of 45 degrees. And I know that cosine of 45 degrees is root 2 over 2 times 5, which gives me 5 root 2 over 2. And then I'll have y equals r sine theta. So r is 5, and then I have sine of 45 degrees. Well, I know what sine of 45 degrees is. That's root 2 over 2. And then I'm multiplying that by 5. So that's going to give me a y value of 5 root 2 over 2. And that should make kind of sense to you as you look at your answer, because they should be the same since it's a 45-degree angle. So my answer is 5 root 2 over 2 and 5 root 2 over 2. And so that would be my conversion point for C. Okay, so now we're going to go back the other way, and we're going to start with rectangular points, and we're going to convert them to polar points. All right, so to do this, it's very similar to what we did last time. One, we're going to draw the picture. Whoops. So we're going to draw our picture. And then once we draw our picture, then we're going to use our conversion facts. This time, however, we are going to use tangent of theta equals y over x, because we're going to need to find what that angle is. And so since we have x's and y's, we'll use tangent. Then we're going to use r squared equals x squared plus y squared, because remember, we need an angle and we need a directed distance. So we use the r squared equation to get the directed distance. We use the tan of theta equation conversion to get our angle. And so that's how we're going to work through these problems. But as before, sometimes when you draw them, you can figure them out without having to do all of the conversions. And sometimes you're just going to have to plug and go through those conversions. So the first thing we're going to do is plot the point -1, +1. So that's -1, +1. So that gives me that point right there. So we're talking about this directed distance at that point. So to get theta, I need to know theta is going to go from here to here, and then I need to know what that distance or directed distance down the line is. So remember, rectangular coordinates are x, y, but polar coordinates are the directed angle and the directed distance. So we're trying to put them in the form of r theta. Okay? So just things to keep in mind as we work through the problem. All right, so we have 1. So when I look at this, I'm going to find theta by using tangent of theta equals y over x. All right, so from my coordinates now, I'm going to put in that information. So I'm going to have tan of theta equals 1 over -1, or tan of theta equals -1. So think about that on the unit circle. Tangent can be negative in quadrant 2 and quadrant 3, but this particular point right here is graphed in which quadrant? Quadrant 2. So the only one of those two possibilities that I need is the one that's in quadrant 2. So what is the angle that would have a tangent value of -1 in quadrant 2? That means x divided by y, or sine divided by cosine, would have to be 1, and so that gives us a pi over 4 angle. So theta has to be 3 pi over 4 because that's the pi over 4 angle in the second quadrant. 1, 2, 3. All right, so now we have our angle. Now we need our direct distance. So remember, we're going to use this second equation for directed distance. So I'm going to use r squared equals x squared plus y squared. I'm using that equation from my circle. All right, so now we're going to plug in our information again. We're going to have r squared equals, and x is -1, and we're going to square it, plus y, which is 1, and we're going to square it, and so I have r squared equals 1 plus 1, or 2, so r equals square root of 2. And that's the distance from the pole. Okay, so once I have the distance from the pole and the directed angle, then I know my point in polar form is actually square root of 2, the directed distance, and the angle 3 pi over 4. Okay, so really just working our way through those conversion facts. All right, moving on to B. Problem B gives us a rectangular point of 0, 2, and we're trying to get the polar point that goes with that. Okay, so then where would we graph 0, 2? 0, 1, 2 would be right here. So I'm guessing you can probably look at this just by knowing what you know about coordinates and tell me exactly what this is. What would the directed angle be from here to here? That would be pi over 2. And then what's the distance down that directed distance? Yes, that's 2. So technically there's your coordinate point, and you didn't have to do that at all. You could still use your conversion facts here and here to work through those numbers if you draw a blank and you can't see it. But in this case, all I needed was the picture to back it up. I could go straight to my answer. I'm good to go. All right, moving on to the next one. All right, so -5, and then I have 5 root 3. So I need to graph this. This is going to be 1, 2, 3, 4, 5. Oops, need a little more room. So I'm going there, and then I'm going up here. So I'm talking about that. And this distance right here would be 5 root 3. And this would be 5. Okay, so that means the angle is going to come from here to here. That's where my theta is. And then I need to find the distance down this line right here to get to that point. All right, so let's find the angle first. So I'm going to do tan of theta equals y over x. So I would have tan of theta equals, and I'm going to do 5 root 3 over -5, because we don't want to forget that distance is negative when we graph that point. And so that's going to give me a tangent value of -√3. So remember, we're in the second quadrant. So what is the angle in the second quadrant that has -√3 as its value? And that means theta has to be 2 pi over 3. All right, so now we have the angle. How are we going to find the directed distance? We're going to use the distance equation of r squared equals x squared plus y squared. So I'm going to have r squared equals -5 squared plus 5 root 3 squared. And then r squared is going to equal -5 times -5 is 25, and 5 times 5 is 25. Root 3 times root 3 is root 9, which is 3. 25 times 3 is 75. So that gives me an r squared value of 100. That makes it nice for my r, which is 10. And we only need to worry about the positive one because really, remember, we're just talking about the runs down this. There'd be 10 of them to get to that. So our coordinate point is 10, 2 pi over 3. Okay, so now we've worked points and converted points in both directions. So this time we are going to convert equations going both ways. All right, so question 4, we're converting equations and we're going from a polar equation to a rectangular equation. So we kind of want to think about, what does it mean when it says r equals 2? When it's given to me r equals 2, that's not a traditional equation. It's not x equals, it's not y equals, anything like that. It is in polar form, and this basically means we have the equation of a circle with a radius of 2 and the center is at 0, 0. So if I draw that, then I know the center is at 0, 0. I'm going to go 1, 2, 1, 2, 1, 2, 1, 2, and so I get this circle like that. All right, so how would I write the equation of that in rectangular form? How would I write the equation of a circle at the origin? Well, that's just going to be x squared plus y squared. And then what about the radius? How do I write that last part in the equation? If the radius is 2, then this value here at the end of my equation would be 4, because remember the equation is x squared plus y squared equals r squared. So be really careful and remember to square that. I get a lot of people that tell me that the equation equals 2 instead of 2 times 2. So just be careful of that. All right, so let's talk about the next one. So what does this mean when we have pi over 3? Well, where is pi over 3? Pi over 3 is in this quadrant right there. That's where you would graph pi over 3. So we're talking about an equation, pi over 3, and so that's the angle. So I'm going to make a triangle right here. So here's theta, which is pi over 3, and I know my pi over 3 angle, the side opposite that would be root 3, then this would be 1, and this would be 2. So if I'm going to think in terms of tangent for that angle, remember our conversion facts, we're going to say tan of theta equals y over x. So tangent of pi over 3 equals y over x. All right, so what is tangent of pi over 3? That's root 3, which equals y over x. Now, think about in terms of a rectangular equation, those are usually y equals. So I want to get y by itself. So that means I'm going to multiply both sides by x, and I get y equals root 3 and the x times x, which is back there. So what is that going to look like? You know, this is the way to think about it, because it's saying a constant value in front of x. So basically this is going to look like a line. It's going to look linear because square root of 3 is going to be a numeric value, and that's going to act like the slope of the line. So this is technically how you would write it. However, oftentimes we see folks do this just because you're less likely to get the x under the radical that way. I personally would take it either way, and you know, either one of these is going to work for me. All right, so you get an idea that you've got this linear line that's going through the origin, and it's going to have a slope roughly the value of that. All right, so the last one is going to be r equals secant of theta. And so basically, I'm going to use a trig identity here, because I would prefer to be dealing in terms of sine and cosine since our conversion facts are in terms of sine and cosine. So I'm going to remember that secant of theta equals 1 over cosine of theta. And so by using that fact and x equals r cosine theta, I think I can get pretty much everything I need for this problem. So first off, I'm going to rewrite it. Instead of saying secant of theta, I'm going to say 1 over cosine of theta. All right, so 1 over cosine of theta. I know that, you know, I have an r value here. I need to get my trig function out of the denominator any way you cut it, but I'm going to multiply both sides by cosine theta. All right, so what happens here? Those cancel. I have 1 equals r cosine theta. Well, remember our conversion factor, is x equals r cosine theta, and we now have 1 equals r cosine theta. So using our equality with our equation, if this is r cosine theta and it equals x, and this is r cosine theta and equals 1, then what must be true? Well, therefore we know x can equal 1. And that becomes our rectangular equation. So we basically were making this equation look like this conversion factor. So that's going from polar equations to rectangular equations. Of everything in this lesson, this is probably what people need to practice the most because making sure you know the procedures to go back and forth makes it faster. Alright guys, this is our last set of problems, and in this set of problems we are converting each rectangular equation to polar. Okay, so keep that in mind as we work through the problem. Again, just basic knowledge of what these equations look like will help you out a long way. So right here, x squared plus y squared equals 9. That tells me that the x and y is at the origin, and what's the square root of 9? 3. So that tells me the radius of this is 3, which means we have to be talking about a circle. So we're talking a circle at the origin. And so we have our circle, which we did this problem from the other direction a minute ago. So if this is the rectangular form of it, then this is actually the polar form. So the equation itself is r equals 3 because we're talking about a circle with a radius of 3 at the origin. So that makes that one pretty easy. Okay, the next one, well, what do I know about this? I know that's a linear function, right? So I know that I'm looking at a line that looks like that and that has a slope of 1. And if it has a slope of 1, then we're talking about this graph right here, and we're talking about this angle where over and up are the same value, so that's got to be pi over 4. So it's not a circle, so we're trying to manipulate to get a ratio of y over x so that we can get to our theta if we don't understand what that is. So what I mean by that is if I take y equals x and I divide both sides by x, then I get 1 equals y over x. And so that to get a 1, we have to move the same direction up as we move over. And the only one of our trig ratios that has that behavior is tan of theta, which we already said was y over x. So tan of theta has to equal 1. And which angle has an angle that has a tangent value of 1? That is when theta equals pi over 4. And so that is actually my conversion. So I used and manipulated to get to this so I could get to my statement so I could get to my angle. So B is pi over 4. Now the last one is a little more involved and it shows up a lot, so it's kind of important to know how to manipulate this equation. Alright, so remember that we have our conversion factors of x equals r cosine theta and y equals r sine theta. Okay, so when we're doing that, what do we know about x and y? So the first thing I'm probably going to do is I notice everything is over here on the same side of the equation. So I'm going to go ahead and manipulate that equation back out just so I have an equation to work with. And so we can look at this and we can say, okay, here's an x and here's a y. So let's just use our conversion facts to get us there. I can say 3 times r cosine theta minus, and replace the y with r sine theta, and that's going to equal negative 2. So I have 3r cosine theta minus r sine theta equals negative 2. So what do you notice in common between these two pieces on this side? I hope you see that they both have an r. So let's factor out that r. Okay, so we factored out the r. Well, what good does factoring out the r do us? Well, it lets us isolate the r in the problem. So I can divide both sides by 3 cosine theta minus sine theta. So I'm going to bring it right up here. And then this will eliminate, and I'm going to be left with the equation of r equals -2 on top, that's what was right here, and 3 cosine theta minus sine theta. And so that's going to be the equation for this conversion here. So you can see when you have more stuff involved in the equation, like the x's and the y's and the numbers, you're going to get a little bit more interesting polar equation. But if you follow good algebra steps here, you should be okay. Make your substitutions for x and y, factor out your common part, and then isolate. Alright, so that is all of the problems. I know this lesson was a little bit longer, but I wanted to take a little bit of time and make sure you had plenty of examples to work from as you work through the problems in the textbook. Thanks guys, see you next time.